Okay, we're going to redo the Unit 1 sample test. So a ball is tossed straight up. Its height is given by this equation. What does the negative 16 tell us about the units for time and height? Well, negative 16 tells us it's in feet and seconds versus if it was negative 4.9, it would be in meters and seconds. So t is in seconds and the height is in feet. Those are the two numbers that you should put on your note card if you don't know those. Okay? Determine the height at 1. So I got to put 1 in for the t's. 1 squared is 1, so that's negative 16 plus 40 plus times 1, which is 40, plus 10. 40, 50 minus 16 is 34 feet, because the height is in feet. At 1.5, we put 1.5 in there. Let's see. Let's do that on the calculator, because 1.5 squared is 2.25. So 32 and 4, 36. Let's see here. 1.5 squared times negative 16 plus 40 times 1.5 plus 10. And we get 34. So the first one, that 1 second, must have been on the way up, and the 1.5 must have been on the way down. And determine when the height was 20. Well, it must be somewhere between 1 and 1. No, it was before 1 second. It was at 20 and after. And so we can actually solve this by graphing. I'll do it a couple ways here. So I don't want to do this equation. I want to do negative 16 x squared. Negative 16 x squared plus 40 x plus 10 and graph 20. So if I push graph, there's the one curve and there's the other curve. Excuse me. And they intersect. So I'm going to find the intersection points by, let's zoom in. Excuse me. Zoom in on right in this area here. There it goes up and down, and there's the 20. Second, calculate the intersection. And that's one of the equations. That's the other equation. And if my guess, somewhere over around there. And it says at 2.218. And it was at a height of 20. And second, calculate the intersection. That's one curve, that's the other curve, and I want to get closer to the other spot. So that's closer. And it's 0.282. Okay, and so t, determine the time in seconds, and explain the meaning of what we just found. Well, this is the height when the time when the height was 20 on its way up, and this is the time when it came back down to 20 feet high. Now, the other way you could have done this is you could have done a quadratic formula. We could have said negative 16 t squared plus 40 t plus 10 equals 20. Now, it's a quadratic, so you need to make it equal to 0. So you subtract 20 from both sides, and you get negative 16t squared plus 40t minus 10 equals 0 by subtracting 20 from both sides. And then that's our B, and that's our A, and that's our C. So in the quadratic formula, it's the opposite of B plus or minus the square root of B squared minus 4 times A, which is minus 16. So I'll make plus times 16 times a negative 10. So that would be actually subtract in the end over 2 times A, which is negative 32. So if you type this in, get the square root, and go minus 40 plus that, and divide it by negative 32, and then minus 4 minus this, and divided by negative 32, you'll get these two answers. Okay, and I explained it already. That's when it was coming down at a height of 20, and this is when it was going up. What does h of 1.5 seconds minus h of 1 second mean? Well, in terms, it's finding the difference in the heights from 1 second to 1.5 seconds. Remember, you always take the end minus the beginning. So the end minus the beginning. So this is the change in height between 1 second and 1.5 seconds. In this case, that difference is 0. It's a difference of 0 is the change in height. Okay. The graph at the right is the velocity in miles per hour. And the horizontal line, and the horizontal axis is time in minutes. Okay. So find the velocity at 30 minutes of the blue car. Now the blue car is the other. Red is the horizontal. So this is the red. And this is the blue. And the red's speed at 40, well, it looks like its speed is, let's see, the red car is the horizontal. And we're supposed to find the blue car at 30. So the blue car speed is increasing. And when we get to 30 minutes, it's gotten up to, let's see, 20, 25, 30, 40. This looks like about 36. So it's approximately 36 miles per hour. Okay? Now, acceleration, I may not have said this enough in class, acceleration is the rate of change of the velocity. If you're picking up speed, you're accelerating. If you're losing speed, you're decelerating. You have negative acceleration. It's the rate of change. And so the average rate of change is just the slope. The slope of the blue car, A stands for acceleration. So the blue one, we need the slope of it at 30. Well, since it's a straight line, the slope is always the same. So looks like it's at 30 at 0. 0, it's 30. And let's see here, at 50, it's 40. So the slope is, the change in miles per hour is 10. It goes from 30 to 40. 40 minus 30 is 10 miles per hour over the change in time is 50 minutes. So it's gaining 10 miles per hour every 50 minutes. Now we could reduce that and call it 1 mile per hour every 5 minutes. So it is going faster, very slowly. Every minute, it takes a minute to go a mile per hour faster. So that's the average acceleration. Make sure you do the units correctly. Now it says determine the distance for the red car, if d is the distance, after 30 minutes. Well, the red car is going 40 miles per hour. So in 60 minutes, it would go 40 miles because it goes 40 miles per hour. But 30 minutes is a half an hour. So it's not going to go 40 miles. It's only going to go half of 40 miles, 20 miles. Now, if you want to look at that, the distance is the velocity times time. The velocity is 40 miles per hour. And so if we're going to multiply by time, time needs to be in hours. And so 30 minutes is 0.5 hours. And the hours cancel. 0.5 times 40 is 20 miles. Sorry, I did that off the screen there. Okay, and describe what the intersection of the two lines means in terms of the situation. This is the velocities, and so this is when the blue's velocity has caught up to the red's velocity. Both cars are going the same speed. Now, I could ask which car is ahead if they started at the same place. Well, if they started at the same place, the blue car was going slower than the red car, so the red car is going to be ahead of the blue car. Even here, the red car's ahead because it was going faster to start with than the blue car. It would take probably the same amount of time. See, 50 minutes, it'd probably take 100 minutes for the red car to catch the blue car to catch up with the red car of going faster. And it turns out it's kind of related to the area in here, which you'll find out in Calc 2. Page 2. The main thing we got to worry about here is, do you know to count spaces, not marks? There's these little spaces, there's 16 of them in an inch. So you got to count the spaces, not marks. So there's 1 space, 2 space, 3 space, 4 space, 5, 6, 7, 8. Yes, I lost count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Or I could count pairs. That would be 1/8 inches. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8, 10/8, 11/8. 11/8 of an inch, or 22/16 of an inch. That's how long that segment is. You could call that 1 3/8, or you could call this 1 6/16. But anyway, that's how you do it. Count the units. Okay, if we got 11 by 17, like we did on our class, if this is 11 inches and 17 inches, and this is 11 inches, and we're going to fold up 2 3/16 on this side, 2 3/16. We're going to have to fold up 2 3/16 on this side, and also on this side, and on this side to make a box. So if this is 2 3/16, the box volume is length times width times the height. So this length is going to be 17 minus 2 3/16 and minus another 2 3/16. So it's going to be 17 minus 2 times 2 3/16. Now, 2 times 2 is 4, and 2 times 3/16 is 6/16, or 3/8. So this is 4 and 3/8. Taken from 17 would be 4 from 17 is 13, and take 3/8 more is 12 and 5/8 inches. The width was 11, and I'll have to subtract 4 and 3/8 from it. 2 and 3/16, 2 and 3/16 twice, so 2 times 2 and 3/16, 4 and 3/8 from 11. So 4 from 11 is 7, minus 3/8 more is 6 and 5/8 inches. The height would be exactly 2 and 3/16, the amount we folded up. Inches. So the volume would be these three numbers multiplied. Now, some of you may not know how to do that on a calculator, so I will. So I got to do parenthesis 12 plus 5/8, 5 divided by 8, close parenthesis, open parenthesis, 6 plus 5 divided by 8, close parenthesis, parenthesis 2 plus 3 divided by 16. That's how you enter mixed fractions. Okay? And we get 182.96. Inches cubed, or cubic inches, because we took inches times inches times inches. Okay, write a formula for the volume as a function of x, where x is the width of the side folding up. Well, just like we did 17 minus 2 times however much we folded up, 11 minus 2 times however much we folded up, and times how much we folded up. Now, if I use technology to graph that, let's see, I think that's my first equation. So I'm going to turn it on and turn that one off and that one off. And then I'm going to do zoom 6. And it goes up way too high, down, and up. Well, I know that the volume could be around 180, probably 200 something. So I'm going to go to my window and make my maximum Y 200, marking it every 10, let's say, graph. And that was high enough to get the max. And the max happens somewhere between 0 and that looks like 4.5 or 5.5 or something. So I'm going to figure out the max here. It says determine the max volume. So I'm going to go second, calculate the maximum. That's somewhere between 0 and 5. And I'm going to guess it's at 2, and it says, no, 2.177. But the volume is 182.966. Oh, that's the maximum. Oh, I didn't. Did I do this other one right? Did I happen to guess the exact right answer here? 12 plus 5/8, 6 plus 5/8, and 2 plus 3/16, 182.96. So we were really close with the size that would make the maximum volume. There's slightly more cubic inches. Make sure you put your units on it. And, oh, this is the maximum volume. I misread the question here. Determine the x that gets the maximum volume. And that was Second, calculate the maximum between 0, enter, 5, enter, and 2 is my guess, and it says 2.1778. 2.1778 inches. This is, see how close that was to 2 3/16. 2 plus 3 divided by 16 is 2.1875, and this is 1778. So slightly smaller gives us a little bit more volume. Okay? Now it says, look at the x-intercepts. Well, there's one at 0. X is how much I'm folding up. So if I fold up 0, I'm going to get 0 volume, and that's how high the graph is. So x equals 0 is, how is it related to the box? Fold up 0 inches makes 0 volume. Okay, what happens here? What's that 0? So second, calculate the 0 that's somewhere between 4 and 7, and looks like it's about 5, and it says it's 5.5. Now, how does that relate to this? Well, half of 11 is 5.5. So if I fold up 5.5 and 5.5, there'd be no width left. No width, so no volume. And the other one is at 7.5. I can go through and find it, but it's 7.5, which is 8.5. Let's check here. Second, calculate the 0 between between 7 and 9, and it says, and I'm going to guess 8, and it says 8.5, which is half a 17. And so if we fold up 8.5 and 8.5, there would be no length. So x equal 8.5, these are all inches. There would be no length to the box after folded up. So the domain for this, what only makes sense is we can't fold up a negative amount, and we can't really fold up more than 5.5. So the domain for this situation is from 0 to 5.5. And I don't care on this one whether you say you can or cannot include the 0 or the 5.5. I'll include them because you technically could not fold anything up, and you could fold 5.5. You'd get 0 for the volume. And the situational range, so if we're only looking from here to here, the range goes from 0 up to that height of 182.966. So the range is from 0 to 182.966. And that's in cubic inches, and that's in inches. All right. If we're going to pour water into a cylindrical vase at a constant rate, the water level is going to go up constantly. So if this is time and this is the height, as time passes, the water's going to go up at a constant rate till it gets to the top, from the bottom to the top. Now, if we do it on one that looks like this, if we pour it in here, it's going to go up pretty fast at the beginning because it's pretty small, and then slow down. So it's going to go up pretty fast to begin with and then slow down as time passes. On this one, it goes from kind of small to wider, so it's going to slow down. So it's be going up but slowing down, so that's going to cause it to curve in that direction till about here. And then it's going to speed up because it gets skinnier. And then at this point, it's going to pretty much the same size all the rest of the way. So it's going to go at the same speed. So it's got to have the same slope as this ended with until it gets to the top. Okay. Miles per gallon, miles per hour. This has time in it. And if you multiply miles per hour by hours, you end up with miles. So using time, hours, to get the distance, you would take 50 times the number of hours. Like if you want 1 hour at 50 miles per hour, you go 50 miles, you'll get a distance. If you do 2 hours at 50 miles per hour, you get 100 miles for the distance. And if you do in the gallons, if you multiply by the gallons, you'll get the miles, because this is miles per gallon. So this would be 30 times the number of gallons. Now, if I want to find T of D, well, this basically says the distance is 50 times T. And so if I want to turn this around, I'll divide both sides by 50. And I get T is D divided by 50. Now, this is not the answer to this one. This is the answer to this. This is my work to figure out this one. Similarly, if I take D and divide it by 30, I will get the gallons. So if I start with D, I want to divide by 30 to get G. This one's a little more complicated. I have to start with T and end up with G. Well, the only one of these that starts with T is this one. And 50T gives me a distance. So now, is there one that I can end up with G starting with D? Well, right here, I can end up with G if I start with D by taking the distance. This was the distance, remember? The distance divided by 30, and that gives me G. Okay, domain. Well, the stuff inside a square root, there's no division in here, so we don't have to worry about division by 0. But we have to have 0 or greater underneath the square root. So 4 minus x has to be greater than or equal to 0. If I subtract 4 from both sides, I get negative x is greater than or equal to negative 4. If I multiply both sides by negative 1 or divide by negative 1, either case, we have to flip the inequality. We get x has to be less than or equal to 4. Now let's just check it. Number less than 4, 0. If I put 0 in here, 4 minus 0 is 4, which I can do square root of 4, which is 2 plus 3 is 5. I can use that. So I got this in the right direction. If I tried to use something bigger than 4, like 6, 4 minus 6 would have been negative 2. Can't do the square root. So in interval notation, I'm going from negative infinity up to 4, including the 4. Inequality notation. Here, R has division, and the only thing we can't do is divide by 0. So this is going to have a domain of all real numbers except 3, or in interval notation, from negative infinity up to 3, not including, union 3 to infinity. This one has division and square root. So the stuff under the square root has to be 0 or greater, but 0 would produce division by 0, so all we have to do is have the 2x be greater than 0. Can't equal 0 because that would cause division by 0. Divide by 2 and I get x greater than or equal 0 divided by 2 is still 0. So from not including 0 to infinity. All right, this has got a double gate. It has to pass into, it has to get through F. And to get through F, it has to be less than or equal to 4. Somewhere between negative infinity and 4. And then we have to be able to take the output and put it into R, which means we can't get a 3. So from this, we can't get a 3. So I write 3 plus square root of 4 minus x cannot equal 3. Let's see what that means. The input can't be. Subtract 3 from both sides, and I get the square root of 4 minus x cannot equal 0. Well, the way I get 0 is if I put 4 in here. So x can't equal 4. I could have squared both sides. That would have been 4 minus x equals not equal to 0. And then I could have added x both sides, and that said x equal 4. So x cannot equal 4, and x had to get through that first gate. It had to be 4 or less, but not 4. So that means x would have to be less than 4 only, which means it would have been from negative infinity up to 4, not including the 4. The first gate here is x squared. Well, x squared can take anything, so far I can put in anything. And x squared, but then it has to be able to go into f. And there it has to be less than or equal to 4. Well, things squared that come out to be 4 are from 2 to minus 2. Minus 2 squared is 4. We can use that. And 2 squared, we can use 4. And numbers in between will be less than 4. So even though we can use everything for x squared, what comes out of x squared has to be less than or equal to 4. If you take the square root, that means it's got to be less than or equal to, it's got to be between negative 2 and 2. Think of this as a parabola, and you want to be under 4. It's going to be the part between 2 and negative 2 and 2. So the domain of this one is from negative 2 to 2. Okay, the distance a car travels depends on its velocity by this equation. The distance as a function of time is the speed times, this should be times time, v times t. Where d is in miles, the velocity is in miles per hour, and t is in hours. Write a function h of s where seconds, s is in seconds, and h returns hours. So if I take seconds, I'd have to divide by 3,600 because there's that many seconds in an hour. If I divide by 3,600, I get how many hours. So if I had 60 seconds, 60 divided by that would be 1/60th of an hour, a minute. If I had 3,600 seconds divided by 3,600, I get 1 hour. So this converts seconds to hours. Now we want a function that gives us the distance based on the seconds. Well, it's velocity times the time in hours, because the velocity was in miles per hour, so we have to convert the time from hours, from seconds to hours, so we have to go times h of s, which means v times s over 3600. The velocity times this number of seconds divided by 3600 converts it to hours times the velocity gives us the distance. Final page. These are functions: f of x, g of x, k of x, g of x, and h of x. This says put 1 into f, so that's 4 times 1, 4 minus 3, 1. So f of 1 is 1, and g of 1, so I go to 1, and g is 0. This says find h of negative 2 and g of negative 2 and add your answers. So h of negative 2 is 1, and g of negative 2 is 3, so I get 4. This says the y value is 3 in the k function. Find what x was. So the y value was 3. What was x? Well, x was 1. Okay, this says g of 0, so we got to put 0 into g, we get 1, and then we have to do f of 1, and f of 1 is 1, and so then we got to do h of 1, and h of 1 is 2. Now it says figure out f inverse of x. So the steps I showed you in class is to change the f of x to y, swap the y and x, then solve for y, so add 3 to both sides, divide by 4, and we have the inverse. So it's f inverse of x is x plus 3 divided by 4. We could check that. If we put 2 in here, we get 8 minus 3, 5. If we put in 2, we get 5. The inverse, we should be able to put in 5 and get 2. 5 plus 3 is 8, divided by 4 is 2. So it works. G inverse. All right, looks like this is 1 to 1, so we can do its inverse. G inverse would be if my x is 3, 2, 1, 0, negative 1, and the inverse, the x inputs that made these y outputs, we're reversing it. We're negative 2, negative 1, 0, 1, 2. Negative 2, negative 1, 0, 1, 2. That would be G inverse of x. Now, H inverse. Well, H inverse is not 1 to 1 because I got a repeating ones on this, so I can't do an inverse function. It's not a function. And now it says do G inverse of 3. So if I do G inverse of 3 goes to negative 2. Or here, 3 goes to negative 2. 3 goes to negative 2. So we got to do f of negative 2. And negative 2 times 4 is negative 8, minus 3 is negative 11. And finally, we're going to draw the inverse of this. So I'm going to pick some nice points on here. Key places, negative 7, 5. This place is negative 4, 4. This place is like negative 2.1, negative 1.8. And this place is 4, negative 4. So now the inverse, I'll start here. 4, negative 4 switched is negative 4, 4. Oh. So this point gets put up there. This point, negative 2.1, negative 1.8, goes to negative 1.8, negative 2.1, almost the same place. Remember, the reflection is over the y equal x line, and so this point just gets moved over there. And this point was connected straight to there, so this point has to be connected straight to there. So this one's almost on top of that line. And so I went from here to here. Now I'm going to go to that point, which goes to this point. So it goes to there. So this almost is on top of itself. And then negative 7, 5 goes to 5, negative 7. And it came off the black line and went kind of naturally curved, not a sharp corner here. So I got to make not a sharp corner and get to this point. So that's the black into the red. Okay,